It's a great movie called Race to Space. Great soundtrack. I've loved it my whole life.
I do love a good space movie. That was my favorite when I was a teacher, when we were doing the space unit and we could spend a day just like watching a space movie. The best.
Yeah.
Hey, we've got a couple guesses. We've got one for Neil Armstrong. Yuri has a guess. Hey, good guesses, guys. The correct answer for this one is actually A. So USSR was the first to put a person to space. And actually during the space race, the USSR had a lot of firsts. They had the first living thing in space, which is Laika, the dog. She was very cute. First human in space, Yuri Gagarin, and the first woman in space, Tereshkova. So they had a lot of firsts, which is a big deal. They're a big powerhouse when it comes to space travel. Okay, we are going to do one more trivia question. I just would like to say welcome and hello to our friends on YouTube. We haven't officially launched our event yet. We're just getting everybody in and organized. So we have time for one more question. How far is the moon from Earth? Now I put miles and kilometers in here in case we have any friends watching from the US. So do we think it's about 6,500 kilometers, 13,500 kilometers, 120,000 kilometers, or 384,000 kilometers? Now in my picture, it does kind of look like the moon and Earth are very close together, but remember the Earth is very big. So think about that when you guys are coming up with your answers. Okay, I see some answers are starting to come in. We think maybe C, 120,000. D does seem like a nice rounded number, yep. 384. All right, our correct answer for this one, guys, is D. So if you wanted to go to space and you were walking, it would take you 9 years to walk to the moon from Earth. If you were driving a car, which I don't think any of the children watching can, if your parents were driving the car, it would take them 6 months to drive to the moon if they were going at highway speed. So that's how far away it is, really, really far. All right, thank you for participating in my chat. I would like to do an official welcome to World Space Week with our special guest, Emma Loudon, who's going to talk to us today about space junk. I would like to say welcome as well to those of us joining from YouTube. I know some of you are not able to join us on Zoom, but feel free to participate in the chat. And for those of us in Zoom as well, if you have any questions throughout the event, just go ahead and pop them into the chat and we will forward them to our speaker. As well, if you guys have something you'd like to share on camera or on mic, just do the little reaction to raise your hand and we will let you unmute and put your camera on and ask those questions as well. So 2 ways for you guys to participate. I think it's going to be a really good event. So without further ado, let's go ahead and get started. First off, I would love to begin with a land acknowledgement. So I would like to acknowledge that I'm joining from Amiskwaciwa-Skayken. So this is colonially known as Edmonton, Alberta. I'm on Treaty 6 territory, which is a traditional gathering place, traveling route for many people like the Cree, the Saulteaux, the Blackfoot, Métis, Dene, and the Nakota Sioux. I would also like to welcome our participants from around the world and across Canada. From coast to coast to coast, we acknowledge the ancestral and unceded territories of the Inuit, the Métis, and the First Nation people that call this land home. Virtual gatherings give us a good opportunity to recognize the diverse territories and the peoples who have lived on these lands and across the globe for generations. So as we move our perspectives up to the sky for today's event, please keep in mind the land that you're on and think about the connections to space sustainability that they can have on your relationship with Earth. Now, a little information about the event today. We're going to try to stick to this agenda as best we can. We will try to keep our event to 45 minutes. I did leave about 15 minutes at the end for you guys to go ahead and ask some questions of our speaker and possibly share some of the work you guys are working on if you have camera access. But throughout the event, if you guys have questions, you can ask them while we are presenting. We don't need to save them all for the end. If you have something that's a really burning question for you, you can feel free to pop it into the chat and we will answer it as quickly as we can. We have a lot of schools joining us today. So quite a few schools are interested in space, it seems like. So we have schools across Canada and around the globe. So joining from Poland, the USA, Pakistan, Peru. Thank you very much to everybody that accessed those resources and took the time to teach their students about space sustainability. I'd like to say welcome to you. Take a look at the screen and hopefully you guys can see your school name up there live for everybody to see. We're very excited and happy to have you. So thanks again for joining us. Now, I would like to turn it over and welcome our special guest speaker, Emma Loudon. So Emma Loudon is an astrophysicist and space entrepreneur on a mission to help people find their place in space. She works at the intersection of academia and the space industry and is a strategic thinker and leader who is passionate about being a steward of the story of the relationship between space exploration and humanity. As an astrophysicist PhD student at Yale University, Emma studies the geometry of extraplanetary systems. Emma uses the kind of thinking spurred by this inquiry to help human development and consciousness that puts the solar system in context. Earth's precarious position in the universe becomes clearer. Welcome, Emma. Thank you very much for joining us today. We are so glad to have you.
Awesome. Thank you so much for having me. I'm so excited to be here and to get to help celebrate World Space Week with everyone.
Wonderful. So I will turn it over to you now. You can go ahead and get started with your presentation.
Perfect.
And I guess I should mute myself because they do not want to hear me talk about space.
Just to confirm before you mute yourself, are the slides showing properly? Perfect. Okay, cool. Great. So I'm here to talk about space sustainability for World Space Week. Now, often we think of the word sustainability. The first thing that I think of is recycling. But then I think of recycling and space. Do they exist together? Like, can you recycle in space? What does that look like? And what does that mean for sustainability? So that's what I'm going to talk about here today. But it's not just going to be me talking about it. I'm going to talk about it with my friend Sparky, who you can see on the slide. She is my trusty astronaut dog, kind of like Laika, who you heard about in the trivia. And she's going to help us think about how space debris and sustainability and climate change are all issues that we can think about from the context of exploring the night sky. So let's start thinking about the night sky. If Sparky goes out in the evening, looks up at the night sky, what is she going to see? What would you see if you walked outside with Sparky? Let's go ahead and pop some ideas in the chat for anything that anybody thinks that they would see if they look up outside at night.
That's a good question. What are we going to see in the night sky? I guess it also really depends on where you live. I live in a pretty bright city, so there's not a lot going on here.
It does depend on where you live. There are a lot of places, like I know people who've grown up in New York City who never saw like any stars at night, and they had to see them only in the planetarium. But there's some great answers coming in the chat. Stars, planets, moon, comets, more stars from our friends on YouTube. Stars, comets, satellites. Awesome. You all are doing a great job. That's exactly what we would see. So I have a couple of specific examples of what I think Sparky would see if she went outside at night. One is clouds. If you go out at sunset and there's beautiful clouds, you can see those clouds in the sky, and they block what I love to do with observations, which we'll hear about later, but they make for gorgeous sunsets. Also mentioned earlier during the trivia session, you can see the International Space Station at night sometimes. If you go online, you can search up where and when the International Space Station is going to pass over where you live. And if you go outside, it's actually bright enough that you can see it yourself, which is pretty cool because you can look up and think, oh my gosh, there's astronauts on that speck of light floating across the sky above me. And that's a pretty fun thing to go do. If you live in a super dark place, you can see the Milky Way. The Milky Way is the galaxy that we live in. And the part of the Milky Way that we can see looks kind of like a band of dusty milk, hence the name, in the sky. And if you have to live in a pretty dark place to be able to see this. But if you are in a super dark place, you can look up and actually see a part of the sky that looks like there's more stars. It looks denser and it looks kind of murky, like it would if you looked in a bowl of cereal. And that's one of the things that you can see in the night sky. That's pretty cool. That's awesome. The full moon in Edmonton is amazing lately. We've had awesome full moons here too. I stop all my friends when we're outside at night and I'm like, wait, look at the moon. And I walked into a tree once doing that because I was so distracted by how pretty it was. The other things that look really pretty in the night sky are shooting stars. So shooting stars come from the tails of comets, which you all mentioned is one of the things you can see in the night sky. When the Earth, as it's going around the sun, passes through the leftover trail of a comet, that's when we get shooting stars in the night sky. It's little pieces of rock and ice falling through our atmosphere and burning up. And as it burns up, that's what we see. And that's what a shooting star is. So there are certain times of year when if you go outside and look up, you can see lots of shooting stars. And in fact, I think that there's one coming up in November. So if you go outside, you can count how many shooting stars you can see in an hour or in 15 minutes. And the numbers can be really high. I make no promises that if you wish on them, any wishes will come true. But that is what a shooting star actually is. It's not a star at all. And as you all mentioned, there are lots of stars to see in the night sky. If you hold up your pinky finger to the night sky at night, the amount of area that your fingernail covers has at least 10,000 stars in it. There's so many out there, and we can only see a tiny fraction of those stars when we actually look up at the night sky. The ones we see are usually the ones that are closest to us, and they're within our Milky Way galaxy, but there are distant ones out there that we can see with super big telescopes that tell us more about the history of the universe. The other thing that we see in the night sky are these weird looking trails of blinking lights. Now, it's not the International Space Station, because the International Space Station is only one object. It's not the Milky Way, because it's too dotted for that. It's not a shooting star, because a shooting star would have a trail, not a line of dots. So what is that? What are these weird specks of light in the night sky? You can put in the chat if you've ever seen them too. I don't know if you have, but I know I've been outside at night sometimes and I look up and I see these specks of light going across the sky, and they're there and then they're gone, and it makes me wonder what it is. So one potential, could it be aliens, UFOs? A lot of people might think so. And I don't know, maybe I wouldn't be able to tell you if it was for real. But in this case, I can tell you that these aren't aliens. And what they are instead are satellites. These are satellites that go across the night sky, and they exist in what we call satellite constellations. So the thousands of satellites that you heard about in the trivia at the beginning, those are the satellites that we see as those specks of dots in the night sky. They're relatively new. People haven't been launching satellites for very long. The first one was launched in 1957, I believe, 1950s. And these satellites as constellations are a super new thing. And what they're designed to do is to bring internet and communication to people around the world who maybe don't have access to internet in other ways. They're also sold as ways to have companies be able to communicate with one another, and they can also be used for Earth observation. So a lot of satellites that orbit around the Earth don't actually look out into space. They look down at our own Earth and take pictures of what we see. That can be used to track wildlife migration. It can be used to track flooding. It can be used to track a whole bunch of different factors that are related to climate change. But while those things are helpful, we also, as a result of the satellite constellations, get these dots in the night sky. So let's see. As you know already, there are a ton of satellites around, or tons of debris around the Earth. And there are actually 4,000 satellites. So there's a difference between space debris and space satellites. So the space debris that you heard about in trivia is any piece of little thing that's floating around the Earth. So these can be the sides of rockets that have launched, and when they separate, they leave those floating around. It can be things that astronauts have lost when they're doing spacewalks. One of my favorite facts is that there's a spatula somewhere out there floating around the Earth that got lost out of the ISS one time. And those little pieces of debris and then the big satellites, both are part of what we call space debris and space traffic. So if you think of a super busy highway and how frustrating it is to be stuck in traffic, you can imagine lots and lots of space traffic in orbit around the Earth. So satellites, not all the debris, in terms of just the number of big, like Starlink satellites, there are Starlink and other companies. There are about 4,000 of them. So that's a lot. And it's way more than we used to have before. So, well, a great question. What happens when a satellite breaks? That creates more debris. So that's exactly why there's a difference between the number of satellites and the amount of debris. So when a satellite breaks, it'll either not be able to keep itself in orbit, so it falls and then burns up in the atmosphere. Sometimes if it's too big, it won't actually burn up in the atmosphere and it'll fall back down to Earth. So if you may have heard in the news a couple weeks ago, months ago now, maybe, I've lost my sense of time, but there was a piece of rocket debris from a Chinese rocket launch that was going to fall back down to Earth, and people were worried about where it was going to land. Now, the good thing is that about 70% of the Earth's land or Earth's surface is covered by water. So when rocket bodies fall back in or satellites fall back down to Earth, most of them are most likely to fall into water or else into like the upper most northern parts of Russia that are not very inhabited. But that's a really important question, especially as we think about how many more satellites are going to be launched in the future. The other option for satellites breaking is like something hits them and they break apart. And then you have more debris, and that debris can hit other debris and create this what's called Kessler syndrome, which is when all the satellites kind of run into each other and you end up with this blanket of space debris around the Earth, which is something we absolutely do not want. It's not a sustainable environment for space exploration or for observation. We wouldn't be able to do science. We wouldn't be able to send rovers to Mars. So helping prevent satellites from doing that is one of the things that is super important. Yeah, the movie Gravity is a great example of that. So what I have here on the slide is the very first few satellites that were launched in the 1960s. So this is what the satellites around the Earth looked like in the 1960s. On the next slide, it's going to show a video of how many satellites we have now and like how it has grown. So I want you to look at those about 10 that are there right now and watch what happens as time passes and we get more and more satellites. So they fill out around the Earth and they're kind of becoming like this blanket around it. Now, it does look like a lot of satellites, and it is a lot of satellites, but space is also really big. So the satellite, you can kind of see that there's like different layers to it. So sort of similar to highways here on Earth, there are orbital highways. There are certain pathways that people want to send their satellites to because they're places where we can look at one part of the Earth all the time, or they're the areas where we put our GPS and weather satellites. But as we get more and more, we want to fill out over the entire globe, basically, to cover for communication purposes. Then you get this blanket around the Earth. But that's our 4,500, basically 4,000 satellites that we have right now. In about 10 years, there are going to be about 30,000 satellites and over 1 million pieces of debris. That is so many more than what we have now, and is something of a problem when we want to think about space sustainability, which is our theme for World Space Week, is how do we make sure that space is sustainable? So I care about that, and Sparky cares about that, because I'm an astrophysicist. So I study these things called exoplanets, and exoplanets are planets that orbit other stars that are elsewhere in our galaxy and in other galaxies. So our own solar system, we have our 8, maybe 9 planets, if you want to count Pluto. I don't, but some people do. But those are only 9 or 8 of our known exoplanets, which is what we call these planets outside the solar system. And these exoplanets are planets that are around other stars. So we orbit our sun, these other stars orbit, or other planets orbit other stars, and they look nothing like our own solar system. And I think that's super cool because it tells us that, like, wow, we're only one way for the universe to assemble a planetary system. And that is something that I find super interesting because it helps us put our own Earth into context and understand. So to do that kind of study that I do of trying to figure out how big these planets are, how massive they are, what they're made out of, how they relate to one another, I use these really big telescopes in Hawaii. These telescopes are 10 meters wide in diameter, so they can collect a lot of starlight for me at night. Because of the pandemic, I don't actually go to Hawaii to use these. I do what we call pajama mode observing. So I can sit here in Connecticut and be all cozy in pajamas, have my hot chocolate, and be collecting photons on these telescopes in Hawaii. I use the data from these telescopes to tell us about the geometry of these systems. So if you think about like our own planet and our own solar system, we have our sun, which is spinning around, and then we have the planets that are going around the sun. And if you imagine the sun and it's spinning around like a toothpick, and then the plane where the planets are orbiting, where the Earth is going around the sun like a pancake. If you stick the toothpick directly into the pancake, that's what our solar system looks like. But it turns out that there are a lot of planetary systems that look more like sticking the toothpick, or what the star is spinning around, into the side of a pancake. So the orbits are polar to the stars. So that's what I'm trying to measure with these really big telescopes. I look at all these other planetary systems and say, do they look like our Earth? Do they not? What does that tell us about how planets form and how planets evolve? And how can that help us think about sustainability and our own role in the solar system here on Earth? If these other solar systems look nothing like our own, then what does that tell us about our responsibility to take care of our own very special planet? So I am concerned about space debris because I want to be able to study those planets still. I want to be able to study them for the rest of my life. I'm still in graduate school, so I've got a lot of years of looking through telescopes to go. And I am concerned that as space debris continues to grow, those telescopes in Hawaii, instead of collecting all the data from the starlight, they're just going to see satellite tracks. They're going to see those dots of light that were in that picture instead of the data that I need to be able to do my science. So that's part of what got me thinking about how do we get invested in space sustainability? What are the ways that we can continue to do ground-based astronomy and at the same time have these satellites that are doing good things for a lot of people in the world? So that kind of brings me back to the great question that was asked in the chat earlier, which is like, what happens when satellites break? Because I don't remember the exact percentage, but a very high percentage of satellites that are in orbit right now are dead. Their batteries have gone dead. They're out of fuel. We don't use them anymore, but they're still up there orbiting. So one way around it is, how do we get the data, or how do we get the debris out of orbit around us? How do we make sure that only what's up there is what we're actually using, so that we don't have as many satellite streaks in our astro data? So I have a question for you. What do we do with waste on Earth when we're done with it? I'd love any answers in the chat on that. What do we do when there's stuff that we're done using, or it's out of fuel, or it's just not working for us anymore? There's something better. Where does it go? Yeah, reduce, reuse, recycle.
The 3 R's, classic.
We love it. Have you ever heard the guy who did the Curious George soundtrack did a song about reduce, reuse, recycle? That's what I think of whenever I hear the 3 R's. Jack Johnson, I think. Yeah. Yeah, no, that's exactly right. Reduce, reuse, recycle. And that is exactly what we do in space, or we can think about doing in space, is how do we recycle? So we're launching all these satellites that have this awesome technology up into space. They get there, but then their life cycles are done, or they're replaced by a newer, better version. What do we do with them? How do we recycle them? Like, one option is to just deorbit them. And that's what it's called when we let them go through the atmosphere and burn up. But that's kind of a waste of really precious metals. It's a waste of resources, and it also can cause problems in the atmosphere, because all those metals burning up can release things that are pretty dangerous to us and to the whole climate of the Earth. So burn up, well, one possibility is not a great option. So let's think about how we can recycle space. So here's your fun fact for the day. We have recycling trucks in space. Just like the recycling trucks that can come and pick up recycling at your house or at school or at work, we have recycling trucks of sorts that do that in space. One is called MEV2. It's the second mission. So even this is a like recycled version of the first one. And MEV stands for Mission Extension Vehicle. So what this satellite does, it's a satellite itself, and it gets launched to space, and then it can attach to other satellites that are up there and refuel them, which makes it so that they can then get boosted back up into orbit and continue going around the Earth and doing their thing. That is one way of making sure that we don't have to launch new satellites also. So it's just one new satellite, the recycling truck, that can then help these other satellites be able to stay in orbit so that we're not launching whole new flocks of satellites. This is important too, because we rely on satellites for a lot of things. While they can be like the problem of space debris is very real, we also depend on satellites in ways that we don't necessarily realize. Our phones all rely on satellites for connectivity. If you've ever gone backpacking, I love to backpack. And so if you carry a satellite phone, which is something you use for that, those phones rely upon satellites to keep you connected when you're in the backcountry. Your regular cell phone also relies upon satellites. Any kind of banking, credit cards, things that are super important to the functioning of our society right now, all of that depends upon satellites. Satellites are why the financial industry is able to keep going. Yeah, satellite radio, great example. We would not have that without the satellites that make it happen. We also use them for weather a lot. They're some of the most reliable resources for tracking things like the hurricane that recently hit the United States, or tracking flooding. They're also, besides just weather, they're also important for tracking climate. So the Earth observation satellites that I mentioned that can take pictures of rainforests, they can take pictures of flooding, and more than just taking pictures and documenting it, they can help us figure out how to move people to where they're going to be able to live in the face of our changing climate, and how to, there are places in the Amazon where satellite photography is used to help predict where deforestation might be about to occur, so that government officials can go in and make sure that illegal deforestation doesn't happen. So these resources are really important. So having some satellites up there is essential to our 21st century society. They're also used for things like going to the moon. I don't know if you've heard, but Canada and the United States are going to go to the moon together later this decade, which is pretty cool. We're going to send the first woman to the moon as part of the Artemis missions. And I don't know if you know your Greek mythology. Have you read Percy Jackson? I don't know if that's still a thing anymore, but it was, and I used to love it. Then you know your Greek mythology, and you know that Artemis is the sister of Apollo. So it's a pretty aptly named mission too. But those astronauts, when they go to the moon, they need to be able to communicate with Earth. And to do that, they're going to need satellites. Like I mentioned, we also need satellites for studying the universe. So there are the ground-based telescopes like I use in Hawaii, but there's also these telescopes like Hubble, there's JWST, there's one called TESS, that all float around the Earth or in places near the Earth, and they collect data that can tell us about the very first stars that were ever born, or the first like atmospheres of an exoplanet. So you know how we measure our own atmosphere, we can measure the atmospheres of exoplanets, which is so cool. Like I'm still blown away whenever I can say that and say that it's a reality. And then, like I mentioned, we also use it for climate. So all of these satellites that are orbiting around us, it's a blanket of satellites around the Earth, but they're also really useful in many ways. So it's a matter of balancing, like most parts of sustainability. It's how do we think about how to create a world where the space orbits around the Earth are clear enough that we can launch that humans that are in the International Space Station stay safe. We heard in trivia about the number of times that the International Space Station's had some close calls with satellites or with other debris. So we have to learn about that, but we also have to think about what these satellites can bring us as the world. So finding that balancing act. How do we build our recycling trucks? How do we build satellites that have longer lifetimes? How do we build satellites that aren't so bright so that they don't interfere with observations from the ground? Those are all challenges that I'm working to solve and that I hope that some of you will think about too. Great questions coming into the chat here. I'll go ahead and answer those. Is there any laws to prevent countries from destroying satellites? Yes. Oh my gosh. So when I was deciding if I was going to go to grad school and be a PhD student and be an astrophysicist, I also debated being a space lawyer and going to law school. So there are there aren't a lot of laws right now. There are very few laws that are trying to protect and figure out how do we manage space? Like, who owns space? Can you own space? Who owns the moon? Can you own the moon? What countries are involved in those decisions? How do we make it fair? How do we make it equitable? So to answer that specific question, there is a law that stops countries from shooting missiles to hit other satellites. It's not a global law. It's I'm only familiar with the United States policy on it, which is that they won't use them. I'm pretty sure that there are other countries that haven't fully outlawed them. In fact, we know that earlier, I guess it was just this year, maybe last year, Russia launched what's called an anti-satellite missile that went up into space, hit a satellite, and then the satellite blew apart into a whole bunch of pieces. And that was when astronauts on the International Space Station had to go into safety mode because there was debris that might have come and hit the International Space Station. And debris, well, you can think of like a little screw or something like that. It may seem like it couldn't do that much damage. When it's flying around the Earth, it's going at about 16,000 miles an hour. And I don't know what the conversion is for kilometers, but it's going really, really, really fast. And it's going fast enough that it can tear through the side of the International Space Station or tear through the solar panels that power the space station. So even little bits of debris are potentially really dangerous for humans that are in orbit in the International Space Station or on other vehicles. Other questions, let's see. But anyway, the space law, super important. We need space lawyers. We need people who are thinking about that because it's going to be critical as we continue space exploration. And this ties perfectly into the next question, which is, are humans still going to Mars? I hope so. That's the plan. So there are a whole bunch of countries that are all thinking about how to send humans to Mars and beyond. Right now, they're starting with the moon. So the Artemis missions are part of this thing called the Artemis Accords that are an international push to try and send humans back to the moon and then onto Mars. Those missions are slated to launch in the next, call it 2 to 3 years, putting humans back on the moon. I don't know if that'll happen. Usually things take a lot longer in space than we think because going to space is really challenging. We have to protect astronauts from a lot of different really dangerous environments when they're in space, and in particular on Mars. Mars has very little atmosphere. So they have to have suits on or habitats to live in the whole time. There's a lot of radiation on Mars, which is super dangerous for astronauts. And the trip will take a minimum 2 years. So it's a long commitment, but long story short, I hope we're going to Mars. What is the best thing to study if you're into space and space travel? I'm going to hold off on answering that question for about 2 slides because it's going to get answered in the next 2 slides. So as we kind of wrap up the slide part, and I can answer a whole lot more questions after that if you're interested. The thinking about space and space debris, so space sustainability is super important. And it's something I think about as an astrophysicist, but it's also something that we need a lot of people from a lot of different backgrounds to think about. So if you walk away from today with anything, I want it to be that whatever you are passionate about, there is a place for you in space. We need people who do all kinds of types of careers to think about the issues that we're going to have going forward with space exploration. So with that, what kind of jobs do you think are related to space exploration? I'd love to hear what answers are in the chat. When you think of space exploration, or you think of yourself doing space exploration, or your friends or your family, what kind of jobs do you think of? Engineering. Yeah. There are a lot of engineers. I have a lot of friends who are engineers who work for different space companies, and they love it. They're really important for building all the rockets, building all the different vehicles that are going to get us there, and the habitats. Astronauts, yes. Space pilots. I love it. Yeah, no, these are all, we need a ton of different people doing a lot of different things in space. And the common answers certainly are like astronauts, engineers, space pilots, and we definitely need those. But we also need lawyers. We need writers. We need accountants. We need mechanics. We need teachers. How about a space princess? Why not? We need diplomats. We need politicians. Whatever you want to be, you can be part of the next generation of space exploration. So I want you to think about, what do you love to do on Earth, and how could you do it in space? Could you do it on Mars? Could you do it on the moon? Could you come up with a new job that wouldn't exist on Earth, but that we might need on the moon or on Mars? 20 or 30 years ago, if you'd said space lawyer, I don't know if anybody would have thought that was a job, but now there are people who go to school for it. Great comment in the chat. Where do the arts play into this? Is art important? Absolutely. I don't know if you've heard of, I'm going to space in the name of the mission, but there is somebody who is sending people to space specifically to create art about it. So trying to send poets and painters and people who build mosaics, writers, all of those kind of different backgrounds into space to be able to convey the majesty of it. There's this thing called the overview effect that astronauts talk about when they go to space, how you look down at the very thin layer of the atmosphere protecting the Earth, and it makes you think about how important it is to protect our planet. So we need people who can help convey those kinds of feelings, and artists, they're amazing at that. So absolutely, we need art. And if you think about too, like movies and science fiction, that's all art. And that's been critical for designing space exploration. A lot of what we have today looks a lot like what some artists dreamed up 70, 80, 100, 200 years ago. So absolutely. Yeah, so with that, I will go ahead and just take questions. Thank you so much for listening.
That's wonderful. Thank you so much. There was a lot there. I was thoroughly entertained the whole time. So I hope the kids enjoyed it as much as I did. So we do have, we'll give you guys a couple. I know we're supposed to end up 45, but we'll give you guys a few minutes because I'm sure some of you guys have some more questions. So now's your chance to pop those questions into the chat if you have any more questions before the end of the event. So I do see we have a couple in here right now. Where do the arts play into it? Is art important in space or space sustainability? I know you kind of touched on that. And then the second one was, how did you get into astrophysics?
Yeah. I will add to the arts one a little bit and say that there are a lot of groups that are trying to use art to help imagine what a future of space exploration could be. So we definitely need art for that too, because it's a really powerful tool to help people be able to see something that's kind of hard to visualize and understand. How did I get into astrophysics? So I love space. I always have. I grew up in Utah, which is full of mountains. So I spent a lot of time outside when I was little star watching. I could see the Milky Way. I was really lucky to be able to see that from my front yard. And I loved learning about NASA, learning about space exploration, but I had no idea that I could work in astrophysics or work in the space industry. I loved it, but I didn't know that that was a job. When I was in 8th grade, I took my first physics class, and that was when I discovered how much I love combining math and geometry to do physics. And then somebody introduced me to the idea of astrophysics, where I can study the math and the geometry of the universe. And I was like, that's for me. I want that. Sign me up. And that led me to do my undergrad degree in it and then continue in graduate school. But I spent most of my childhood wanting to be a dancer. I wanted to be a teacher for a while. I wanted to be a part of a circus for a long time. So I didn't know that that was even a job for a while. So when I ask you to imagine like what kind of jobs are out there that you might not even be thinking of as a job, I say that from personal experience because I know that if I had I go back to like things that I made when I was little, kind of like imaginary games. And I designed a lot of worlds where I was doing kind of what I do today, but I didn't know that it was a job. So dream up, dream big about those jobs, and you can find your place in space with them. Is Saturn the biggest planet? Okay, so I love Saturn because I think it's just so cute. It's like big yellow, it's got those nice rings around it. There's always the image of like, would it float in a bathtub? Because it's really not very dense, and it would float in a bathtub if you had a really, really, really big bathtub. But it's actually not the biggest planet. The biggest planet in our solar system is Jupiter. Jupiter is also gorgeous. If you look up or have your teacher look up or parent look up the Juno spacecraft images of Jupiter, they are stunning and are actually taken by spacecraft that orbit these planets, which is also so cool. But there are planets that are in others around other stars that are even bigger than Jupiter, which is kind of crazy. But they're big, they're made out of gas, and they are so big that they have these bands of like different weather around them that's on a whole different scale than the different weather that we have on our own planet. So super cool. Let's see here.
Sorry, just so you know, I'm like Googling things in the background. I found some pictures and popped it into the chat here. So you guys can see there's a link to see some of those Juno images she just talked about.
Amazing. Yeah, they're so cool.
And I think the next one was what is your favorite planet, which you kind of were already chatting about, but interesting.
Yeah. Oh, and I want to get back to the study to school thing too. Okay. So favorite planet. So the like, cheesy answer to that is Earth. I love our planet. It's so special. The like not that not that answer is so there are these planets that are around other stars. We don't have them in our own solar system, but they're called hot Jupiters because astronomers are super creative at naming things. And they're planets that are very close into their star, hence hot, and they're the size of Jupiter, hence Jupiter. Like I said, we're pretty creative at naming things. So these hot Jupiters orbit, their year is about 2 or 3 days long. So it's really short. And it's called being tidally locked to the star. So our moon is tidally locked to the Earth. So we only see one side of the moon. And the same thing happens with these planets. The same side of the planet is facing the star all the time. So that means you have one side of the planet that's super hot and one side that's super cold. And we can measure the weather on these planets that are light years away with those telescopes like I was showing in Hawaii. And I think that's super cool. So they're my favorite planet. The best thing to study in school if you're into space and space travel. So anything. We need everyone in space, meaning people who do all types of things. If you want to do a more a more established route into space, then engineering and science and physics are all really good. I always recommend physics no matter what. Some schools have astronomy courses. If not, this kind of answers one of the other questions about YouTube channels. There are great resources online to learn a lot about astronomy. I'm in a space on the name of the guy is I think it's John Green's brother. He does the YouTube channels that are like brief history of X, Y, and Z. And there's somebody who does those for astronomy as part of the same program. It's funded through PBS here in the US, I believe. And they're awesome. They're a good way to learn about astronomy too. There's also a lot of good astronomy books out there. If you go to your local library or to local library or to local bookstores, there's usually one or two, maybe more, hopefully, really good books to be read about space that are really fun. I love The Martian. If you're interested in like a good novel that's science fiction, that book is really great because it's well researched. The science in The Martian is all possibly like something that could happen. It's not just made up. So that's a really good one to read. Trying to think of what other good, specifically YouTube channels are awesome. There's a woman who goes by the name of Astro Athena who does some good stuff. And then, oh, if you have Netflix, the space gal, Emily Calandrelli, is one of my favorite humans in the world and has this show called Exploration Space, and then also has a show on Netflix about like home science activities. And then if you're on TikTok, she's awesome on there too, and gives like tons of science and space information all the time. So those are great.
I know the kids watching are all probably pretty obsessed with YouTube. So I feel like now they're just going to be going home and like Googling all these YouTubers. We probably do have time for like maybe 1 or 2 questions. So if you have one last burning question, feel free to pop it in the chat. This is kind of our last chance to get a couple in. While we just wait for those last couple, the last thing I always ask our speakers is, do you have any words of wisdom or any takeaways that you would like the kids to have at the end of this event?
Yeah. So the biggest takeaway is that you have a place in space, no matter what you're interested in, what you're passionate about. If you want to be part of the next generation of space exploration, there is a place for you in space. We need everyone. The jobs are, what I love about this field is that like the careers, the work, it's being kind of like made up as we go, because it's a new thing. It's a new pathway. It's a new type of exploration. And that is so powerful. It's a kind of exploration that forces us to change our thinking about the world. And that change in thinking can help us have inspiration for how to interact with our own planet, with the rest of the world, to think about how do we battle with climate change? How do we work together to be a more inclusive world? All of those things are things that we think about as we go about space exploration, which is why I think it's so powerful. So whatever you want to do, there is a place for you in space. There's an awesome, great question that just came into the chat, which is, are there any plans or work for honoring Indigenous people through space? As you know, they had their view and perspective towards space. Yes. So this is a great question. There is some work being done towards this. There is concern about satellites because people think about this night sky as a big part of Indigenous culture and cosmology. Looking at the night sky, looking at constellations, all of those activities are in many cases integral parts of Indigenous cultures. So trying to protect the dark sky as a resource is the wrong word, but as a place that needs protection for Indigenous cultures is something that is being thought about at a international level. There's also, I went to this interesting conference in Hawaii a couple of years ago because Hawaii is a place where the Indigenous cultures there used the stars to be able to navigate across the entire Pacific Ocean. And there's this incredible culture of what's called wayfinding. And it was trying to think about how can space exploration and astronomy and Indigenous cultures all work together to, as we think about sending humans out into the rest of the solar system and beyond. Oftentimes, Indigenous groups that have been living in some of the most extreme environments on the Earth, there's a lot that can be learned about human survival as we send humans off to the most extreme environments in the solar system. So great question, and definitely something that the community is thinking about, probably not as much as it should be, but those conversations are happening, which is really important.
Yeah, that's wonderful. It makes me think back to when I got to teach the space unit when I was a teacher, and it was always so fun to do the Indigenous perspective and kind of show kids how we've thought about space over the years. You got to think about how amazing space must have been before we had all of these lights everywhere. It probably was absolutely amazing.
You can see the Milky Way everywhere.
yeah, it would have been so cool. So I just wanted to quickly, before we do our final thank yous, I had a quick reminder for everybody watching. If you guys enjoyed this event today and you want to do something kind of similar, we do have more events coming up for elementary students. So you can go ahead and scan the QR code on the screen, or I just also popped the link in the chat. But we have an event coming up for World Food Day where we're going to talk about sustainable fishing. So sustainability is a big theme this year, and for good reason. So yeah, if your students enjoyed this, please make sure you check this out. Check out our link tree so you can sign up for our future events. And I would like to do a final thank you. Thank you to all of our students and classes who participated. We loved seeing your questions. I'm sad we had some camera shy classes today, but hopefully next time we could see your little faces. But we really appreciate all the participation that you guys did. And a huge thank you, Emma. Thank you so much for your expertise and your wonderful presentation. We really thoroughly enjoyed having you, and we hope that we can do it again.
Thank you so much. Thanks to everyone for the participation. That was awesome.
Yeah, it was awesome. And we have 5 minutes to spare. I mean, I know we're technically 10 minutes over, but I'll let you guys go 5 minutes before the hour. Thanks again, everybody, for the participation. And we look forward to seeing you next time. Have a great day, everyone. Thank you. Thank you. Emma, thank you again so much. This was absolutely wonderful.
Thank you.
Yep. Thanks, guys.